Hello, we are moving into section 4.3 of your textbook, which is in Unit 3, all about statistics. We are looking at measures of dispersion right now, so these will be some pretty big calculations. I would recommend getting a calculator before you start this, and definitely something to write on. So today we're going to learn how to find the standard deviation of a data set, and then examine the dispersion of data relative to the mean. We're going to start with this warm-up. This will be a little bit of a review. Who is the better bowler? We're going to calculate the mean, median, and mode score of Danny and George to support our answer. So go ahead and pause the video, calculate the mean, median, and mode for both players. All right, you are back, and hopefully that you have calculated the mean, median, and mode for Danny and George. And you probably noticed, or hopefully noticed, that the mean, median, and mode are the same for both people, and they're all 185, right? So George's mean, median, and mode is 185, same with Danny. So right now we don't have anything really, we could stop and say, well, they're just as good of bowlers as the other, so they are exactly the same. But that's not true because we don't have exactly the same scores. So we are going to need different types of calculations to help us with decisions like this. So this is an example of where just measures of central tendency can fall short. There's what that says. Okay, so deviations are what we're going to move to now. So a deviation is the difference between a single data point, x, and the mean, which we know as x bar. And this is called the deviation from the mean. So we take like, all right, how far away is our data point from the average? That's our deviation. Furthermore, the sum of the deviations is always equal to 0. So you'll have a little to the left, a little to the right. That'll add and subtract to equal to 0. So like, for example, you could be less than the mean, so you get a negative number, but then you'll have some that are also greater than the mean. That's a positive number. So when we add them all together, we just get 0. So just adding those up doesn't really help us. So we need to square deviations to help us, and that's where we're going to start heading today. Right? So variance. Variance, given a sample of n data points, the variance of the data, I said data and data, interesting. The variance of the data is found by squaring each deviation, adding the squares, and then dividing the sum by the number n minus 1. All right, so I know that sounds a little crazy. We are going to note variance as s squared. All right, so we add up all of the deviations, that's in here, we square them, and then we divide by the total. So this is essentially an average that we are calculating, and it's an average difference from the mean right here. That's what we are calculating, that is variance. So the variance of a sample is found by dividing the sum of the squares of the deviations by n minus 1. Okay, so this you should keep ready today. Standard deviation then just goes one step further, and we take the square root of s squared, so we just get s, right? The square root of the variance. So that is our standard deviation, and so that's where we're going to spend some time today. All right, so here we are. George has bowled 6 games, and his scores were 185, 135, 200, 185, 250, and 155. So we're going to find the standard deviation of his scores. And remember that the mean was 185. Okay, so first thing we need to do to find the standard deviation is we need to find the deviations. So what's all the difference from 185? So we could take, all right, well, we take 135 minus 185, that'd be negative 50. We could take 155 minus 185, that'd be negative 30. 185 minus 185, that's 0, and then 0 again. Notice that these are put in numerical order, all right? And then these would be positive. So 200 minus 185, that's 15, and then a big difference there. I'm going to escape out of here and show you that, oh, hold on. These are I'm gonna add a color again. Where's my, yep, okay. All right, and there's those ones. So they were there all along. Bam. Okay, so there's that one. And then I'm gonna do the same thing with over here. So we're just squaring this value. So negative 50 squared, that's 2,500. So we just squared to get this next category, alrighty. It's back, present. All right, so we're squaring this to get this category. That's all lovely. And then when we're finding variance, we take the sum of all those squares. So I'm gonna go back. You add all of these up. Add, 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 add. We get 7,850 divided by, there were 6 scores minus 1. And we do the minus 1 so that we have an underestimate instead of overestimate. And so then we have 1,570 is our variance. All right, but then remember, if we want a standard deviation, we need to take the square root of this. So the square root of 1,570 is 39.6 points. So our standard deviation for George was 39.6. What does that mean? That means that, he'll average about 185 points, but he's got some big swings going on, about 40-point swings, either better or worse. So we could then calculate Danny's, and if Danny's is a little bit lower, then he could be considered the better bowler because he's more consistent. All right, so what does this mean? I kind of just talked about that. You can calculate Danny's standard deviation. It was only 3.7. So he's at 185 points and consistently sticking there, like he's only swinging a couple points. So he's more consistent. So we could say that Danny is the better bowler. There are alternative methods for finding variance, and it's kind of this big, nasty little calculation, but really you only need to calculate 2 things for the oh my gosh, what am I thinking of? The deviation. And so it's really only like 2 big calculations, and then we can plug it into this. So this does become helpful. Note that square each data point and then add is what's happening when we do the sum of each. So we're gonna, okay, wait, this backwards. This means you add up all your points and then square it. Yeah, good. Okay, good. That's right. So this means add up all your points and then square it. This one means add up the square of each point. So you got to square each along the way and then add them all up. So that's just what this is saying, the difference down there. This should have a little square in it. That's a typo. Whoops. All right. Find the variance and standard deviation. So we're in 2008, the U.S. Bureau of Labor Statistics. We've already actually talked about this one in the last section, but we're talking about how many people are earning minimum wage in 2008 across the country, and that information is below. So we want to find the mean age. Oh wait, no, that was the last problem. That's what we did last week. Now we want to find the standard deviation. Okay, I copied and pasted, but now we're going to find the standard deviation. All right. So here we go. Okay. First thing that we need to do is, I don't know, I kind of like organizing it in a table. You can too. But we have intervals here. So we can't just add up all the data. We have to take a midpoint approximation. All right. So this is basically counting just what we did previously as X. Now we're doing frequency times the midpoint to get that like X value that we were talking about. So we would multiply 180,000 workers are ages 16 to 20. The average age of that is 18. So what we're calculating here are the total ages for that group, but we're having to average it. So this is the number of 18-year-olds there, all those ages added up. Okay. Then we can also do x squared, which means we would multiply this number times 18 again, and that will help us with this formula again for x squared. Okay, so that's where we're headed. Okay, and so I'm just filling out the rest of the table. We have the midpoint. We're multiplying this times this to get this, and then multiplying by another x, 22.5 to get this. All right, we're totaling at the bottom, and I'm kind of flying through this, but pause the video, look through the table, and make sure you're getting the same calculations. All right, so now we're going to apply the alternative formula for sample variance, which was this guy. Okay, so n minus 1, we had 277,000 people interviewed minus 1. This is what we calculated for f times x squared back here. This is the total. Okay, wait, right here. Okay. And then this was the other calculation, which we can now square. That's the x squared summation divided by our total number of people. So this is just simplifying along the way. We end up with a variance of 191.329, all this stuff. That is our variance. Okay, so one more step. We need to take the square root, and we find that the standard deviation from the mean is about 13.8 years. All right, so what does this mean? This means that the standard deviation of the ages of workers receiving minimum wage is 13.8. Okay, and this will become helpful when we start talking about like what percentage of people that is, and that is going to be a massive percentage. What we're going to find is that a majority of in a majority of cases, I suppose, being within one standard deviation within 13.8 years of the mean is going to cover the majority of the workforce. Okay, so here's that picture. And here's that alternative variance that we just used where we have f times x. This is if we have grouped data. All right. So if you are within one standard deviation of the mean, right in here, that should be the majority of our population. And as we move farther out, there's going to be fewer in these kind of outskirts if we're looking at a typical bell curve. All right, so one more thing where we're going to use those percentages a bit. Pocky Mallory is a rabbit enthusiast and has 11 mini Rex rabbits that she enters in regional rabbit competition shows. The weight of the rabbits are given below, and what percent of the rabbits' weights lie within one standard deviation of the mean. So now we're looking for a percent, all right? But we can calculate the standard deviation first. So we need to start by finding our mean. So we can add all these up, divide by 11. There it is. Add all the data points. They all add to 680. Then we can, also sum the squares. This will be a handy number later. So, whoops. So you take 58 and square it, plus 66 squared, plus 54 squared, plus 63 squared, on and on and on. Add all those up. We should get 42,186. So then the mean, that was all of our x's added up, divided by 11. The mean is 61.8 ounces for the rabbit. So the average weight for the rabbits are 61.8 pounds, or sorry, ounces. Then we can plug into our alternative formula for variance. So we have 1 over n would be 11. X squared, we calculated up here, the sum of x squared is 42,186. The sum of x, we just had up here, 680, so we could square that, and then divide it by 11. So here that is, and then we can just simplify. We get that the variance is 823 divided by 55, or about 15. But I'm going to take the square root of that fraction just to be more precise. So our standard deviation is 3.8 ounces. Okay, so if we want a percent, we are going to take our 3.9 ounces and find all of the rabbits that are within 3.9 ounces from the average. Okay, so here's the average. All right, we could subtract 3.9, that gets us to 57.9, or we could add 3.9, that gets us to 65.7. So all of these rabbits in here are within one standard deviation of the mean because the standard deviation was that 3.9. Here's the mean. All right, so we count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8 rabbits in there. 8 out of the 11 means 72.7% of the rabbits lie within 1 standard deviation of the mean. And I know that was super fast, but please come in with questions. That is the end of 4.3.